40%. But half of our marks, 20 marks, came from the atom question in section B. So my point is,
20 out of 20.
yeah. So the atom question is a question you can prepare well for and do well in. The fields that we're going to do now is the hardest question. So you shouldn't do it in section B, but you cannot avoid it because you have section A questions to do on the topic anyways. The section B version.
Yeah.
The section A is okay for, I don't know, it depends on what you prefer. I think the mechanics is sometimes easy and sometimes hard. It depends on the year.
So if it's last year it's easy, it will come back.
There. Huh?
If the last year it was difficult, that means it will come easy.
Not necessarily, I'm afraid to tell you. Okay. Anything else I need to say before we start the new chapter? No, again, it's not that big. All the chapters in semester 2 are medium length. They're about 10 topics each. So if I look here at fields, 10 lessons as well. So we'll start with electric fields.
So we still have fields and atoms and that's it.
I was discussing with Ms. Sharif as well this morning about what to do in ESAP because this Monday you've finished all your coursework, so there's no point in giving you time in school to work on your coursework. I need to design something for you to do in ESAP, and I was thinking of focusing towards exam questions in ESAP. Do you have any thoughts on what you would like to do in this extra hour?
Okay.
Yeah, well, not. I don't mean a particular subject. I mean, what things do you want to do? See, I was thinking about making it more like an exam prep type of class, except exam prep for physics or exam prep for maths. Do you know what I mean?
One each.
Maybe like
alternate.
One per week.
Yeah.
Can get like exam papers and
Yeah, this is what I was picturing. Something to do with exam papers. Did you do that ESAP lesson in semester 1 where you had to read an exam paper and yeah.
Mechanics.
Identify.
Do you find that useful?
That was one of the most useful ones.
Yeah. So we want to be doing stuff like this then in the SAP. Yeah.
I prefer the exam questions and maybe like we can check the lesson we took like one of your videos in class.
Oh yeah, okay.
And just solve.
That's a good idea too. I'll have a think about it. Okay, electric fields then. You got that? Yeah. Right, so first, before we can talk about anything about electric fields, just a little bit of revision, kind of revision. We have talked about charge before of an electron. Electron is what type of charge? Positive or negative? Negative, of course. So a lot of subatomic particles have a charge, an electron and a proton, for example. Which particle does not have a charge? Neutron. Electrons are negative while protons are positive. So you don't have to write this down because you do chemistry. This is a basic chemistry fact as well. Things that are negatively charged and things that are positively charged attract each other. This makes electrons and protons stick together. Things that have the same charge push away from each other. They repel. Again, you don't have to write this down. This is basic chemistry. But now on to something new. So what the heck is an electric field? So an electric field is a vector field, and again, what's a vector field? I'll have to explain that. That shows the direction that a very small positive charge particle will move when placed in the field. So this is the technical definition of an electric field. I can explain that in more detail in a moment. Okay, you got that? Okay. So what is a vector field? So the example I give of vector field is like something like wind, for example. So I'll just draw a wall here. So we'll imagine there's wind blowing from the north. And the way we draw the wind is with arrows. And these arrows are like force arrows. The bigger the arrow, the more force there is from the wind. But you notice that there's some places you could stand, if you were like a little red ball, if there's a little ball here, it will have less force than if it was, say, like here. So this is what I mean by a vector field. It's like a field of vectors, and the vector represents the force, where the push is. Do you understand what I mean?
Yes.
No? What's confusing you? What can I explain more? You know, when it's windy, sometimes standing in certain parts would make you feel more force. Like if you stand behind a wall, you would feel less wind. So it's like the wind is smaller here. These vectors represent the force of the wind. So it's wrong to think about the wind as just being one big force coming down, because it depends on where you stand. So this is what I mean by a vector field of force. It's representing the different forces at different points. So an electric field is a vector field, except instead of wind and so on, it is what way a small positive charge would move. So instead of having wind, you imagine you have a small positive charge. If the positive charge is put here and moves to here, then we say there's a vector field this way. Imagine if I put the charge here instead, and instead of moving to here, maybe it swings around the corner and then ends up here. Then this is the vector field here. So what you do is you keep placing small positive charges in different places, and this way you can build up a picture, and maybe you'll end up with some picture like this, for example. And wherever you put the charge, it moves along the path. Do you get the idea? Yeah. So, do you have this definition? Yes? Okay. Right, continuing. So that's a picture, but it's a big picture, so it's taken a while to load. Right. This is an example of a vector field. You don't need to draw this right now, because later I'm going to have more pictures I need you to draw. This is just to help you understand. So, if I put a charge particle near a positive particle near a positive particle, what will happen? Repel. So that's why the arrows point to the left here, because if you put a small positive charge here, it will be pushed to the left and attracted to the negative. What about if I put a small positive charge here, attracted to the negative? So this is the vector electric field. This is the electric field here. It shows the movement of positive charges. If I put the positive charge here, it will shoot off this way.
What if we put two negative charges?
Yeah, we're going to have all the diagrams for the combinations you can have. So we can have like positive, positive, negative, negative, all different types. So we'll see what, I think I'll do them in this lesson. Loading? Yeah. How do we measure charge? You remember it's with the Coulomb. The Coulomb, we did this definition in electricity, but if you forgot it or if you don't have it, you can write it down. A Coulomb of charge is the amount of charge you get from 1 amp running for 1 second. This is 1 Coulomb. It's 1 amp for 1 second. What I maybe didn't give you in the electricity chapter is the charges on protons and electrons, although I think I did. These are built into your calculator anyways, and they're in the exam formula book. This is the charge of a proton. This is the charge of an electron. And this is the charge of a neutron. And by the way, I might as well give you the masses as well. This is the mass of proton. Have you done that in chemistry? Yeah, it's a small number. An electron is even smaller. Yeah, smallest. And neutron is about the same as a proton. And to 2 decimal places it is the same. Although technically it's not exactly the same. I can't remember, but one of them is a bit heavier. I don't remember which one. Is it? You know this for a fact?
Yes.
From chemistry?
Yes.
Great, okay. So the proton is a little bit heavier than a neutron then. Okay. Again, you will need these numbers for some of the questions if you want to write these down.
You don't need the math.
Oh, you do. For some of the questions, you'll need the math. Okay, got that? Yep. Yeah? Are you sure? Yeah. Note often this is just written simply as E, or actually, yeah, I think it's E, or maybe it's minus E on the calculator. Anyway, so don't worry about that right now. Okay. Different parts of the field will be stronger or weaker than other parts. After all, shouldn't small positive charges fly away faster if you put them nearer to a positive charge? So if you have a positive charge here and you put a small positive charge near it, it should fly off. Whereas if I put it here, it should just kind of roll away. This leads us to the idea of what's called electric field strength, how strong the field is at different points. So the definition of an electric field strength, E, is defined as the force experienced by the unit charge of particle. So that's really it. Mathematically, electric field is defined as force felt by the particle divided by the charge of the particle. So in other words, it's force per charge is the electric field strength. So then the unit, of course, is newtons per coulomb, obviously. Right, so this is our first new definition of today. Same as what? What's your idea? Oh, you did one of this in high school? Possibly. Continue. You don't remember. Have you done this before? Yes, continue now. Okay, Ms. Sharif, continue? Okay. Let's have a look at a question. So a current is running through a copper wire and there's an electric field around the current. The electric field strength is 10 to the minus 25 newtons per coulomb at some distance from the wire. What is the force felt on a free electron at this distance from the wire? So what I'm saying here, you can draw it if you want. You have some wire, and around the wire there's some electric field. So that means if you put a positive charge near it, what will happen? It will feel a force. Okay? So there's now some force acting on the particle. How much is this force? Well, the formula is E equals Q, alpha for Q. So that means F equals EQ. I give you the E, it's 10 to the minus 25. And I give you the Q because I tell you it's an electron. Is that constant 27 on the calculator?
27 is R.
Oh, what's E?
23.
Close.
Is that different than the other?
I'll tell you the moment I see it on the screen. Yeah, so times 10 to the power of minus 25.
But,
I know there's a minus, but I don't care about the direction. I just want to know how big the force is. A tiny 1.6 times 10 to the minus 44 newtons is how much force the electron experiences near this wire in the electric field.
what about the direction of the drawing?
That is a separate lesson, the direction of the field. We have special rules for that.
No, but like, is it going to go to the wire or away from the wire or with?
I'm deliberately not discussing that because that gets its own lesson. So I'm leaving it a mystery for the moment. You might remember them from physics, but we have things called the right-hand rule and the left-hand rule. See, he remembers. Yeah, yeah. I see students in the exam. I know which question he's doing. He's going. Okay, continue. Right. An electron is placed a distance from 3 protons. What's 3 protons? 1 is hydrogen, 2 is helium. Is 3 lithium? Oh my goodness. Is it? Is lithium 3? Do you have a periodic table with you?
Yes, it's lithium.
It's lithium? Anyways, whatever it is, an electron is placed near 3 protons. So the electron will be pushed away. The field strength is that. What is the acceleration of the electron? Use plus to mean inwards and minus to mean outwards. So I do want you to put a sign in. Okay, I think you should be able to do this one because it's very similar to the last example. There's only one formula for today. So try it for a minute before I do it. Is it lithium? Yeah. I'll draw what's happening if you're wondering, if you're unsure. You have something like lithium, 3 protons, and then you place an electron here. So what way will the force be? This way. No, what am I saying? It's so stupid. The force will be attracted because they're opposite. And I said plus is in and minus is out. So in this example, the force will be a positive, we should say. Okay, so I want you to calculate now the acceleration. I'll give you a minute. I'll give you a hint if you're stuck.
No.
Alright, okay. No, that's better for you if there's no hints.
The Q is the electron.
Yes, good question. Is the Q the electron or is it the 3 protons? Correct. It's the thing that's moving in the field.
The atomic number is the mass number also, yeah? The atomic number is the mass number.
Yeah, 3 protons, yeah.
Done.
Got it? But you just tell.
I got the idea.
Yeah. So where's the
M
end?
is equal to
Yeah.
1.41 multiplied
Yeah.
in the electron and
That's it.
F over the mass of the
Yeah.
electron.
F E equals F over Q. So that means F equals EQ. But we don't want F, what do we want? A. So Newton says this is MA equals EQ. So then A equals EQ over M. Do we know the E? Yes, it's given to us. 1.41 multiplied 10 power. Good. Do we know the Q? It's an electron. So that's shift 723. And then finally, do we know the mass of the electron? Is that constant number 1, 2, or 3 on the...
9.11.
Yeah, but I'll get the exact number. It should be MP, ME. Which one's ME? 3, is it?
Should we multiply it by 3 because it's the 3 proton?
No, it's just the electron we care about because it's the one that's moving. So, that multiplies the charge of electron over the mass of an electron. You can type the full number in if you want, but this is more accurate and easier for me to do. We get a final answer of 2.48 times 10 to the minus 13 meters per second squared. A very, very small acceleration. Continue. Musharif?
Yeah.
Right, that's you.
What is dynamic? Children.
Acceleration?
And
Okay. Still got a couple more to do. A small dust particle of mass 1 milligram and charge of minus 100 E, so that means it has a charge of minus 100 electrons, is placed between two horizontal plates. The plates produce an electric field. The small charge is held balanced between the two plates and does not fall. How strong is the field? So what's happening here? You have a small dust particle. It should fall down, but it doesn't. Instead, it's kept balanced. So there must be a force pulling up on it. The force that's pulling up on it is the electric field, because the particle is inside a field and the particle has a negative charge. Oh, actually, so I kind of drew my arrows the wrong way here. Anyway, that's not too important right now. I tell you the mass is 1 milligram and the charge is, what did I say, minus 100 electrons. And my question was, how strong is the electric field? What is the electric field strength? How strong does the field need to be to hold the particle and stop it from falling? I think you can do this. If you think about it carefully, it's not going to be that hard once you get the key idea. Don't say it. I think you have it. So you started. Try and do this. I'll give you a minute and then I'll do it. I know you really want to say it.
no.
Can you go back to the question?
Oh yeah, sorry, yeah.
What does mg mean? Milligram?
Yes. Milligram. You have to use kilogram. So how many kilograms is a milligram?
Let me see.
No. Correct. Got an answer? Yes, sir. Are you going to buy a calculator one day? A good calculator?
For now, I'm
It'd be good for the exam.
I think till now I don't need it. Only for the fresh shop.
Okay, if you say so. We got answers? Okay. Musharif, or no, maybe not Musharif. Did anyone figure out the key idea for solving this? What force? Yeah, this is the weight, and this is the force from the electric field. Yes? So the force from the field must equal the weight, which means QE must equal mg, which means E must equal mg over Q, which must equal the mass, which is 10 to the minus 6 kilograms, times g, yeah, all over the electron, whatever it is on the calculator.
100.
Oh, thank you. Thank you. 100.
Minus.
I don't care about the minus. Electric field strength is a positive anyways. I know what you're asking, Adnan, and I'll explain in a moment. 6.13 times 10 to the 11? No, sorry, 6.12 times 10 to the 11 newtons per coulomb. You want to know why is it 10 to the minus 6, isn't it?
I want to know 10 to the minus 6 is like
0.5 zeros and a 1. 6 zeros in total. Was that all you needed to know? Ah, okay.
What did you want to say?
How milligram is 10 to the minus 6?
Grams is to the minus 3 and milli is to the minus 6.
Grams
Yeah.
squared.
Grams squared?
So minus 3 and minus 2
Cor-
and minus 5.
No, minus 3 and minus 3. Don't listen to his square business.
Why minus 3? No, I said minus
You said minus 3.
Yeah, it is.
yeah, once, and the second time for the milli I said minus
No, milli's minus 3.
3.
Centi is minus 2. Okay. Yeah, like millennium. Okay. The kind of trick question. A proton and another proton are fixed at some distance apart. What is the field strength at the middle? Yeah, but why? Why? So you have a proton and you have a proton. So remember the definition of field strength. It's how much force a unit of positive charge would feel. So let's put one positive charge here. It will feel a force. It will be pushed this way by this one, and it will be pushed a little bit this way by this one. So it will probably head off this way. However, if you put it right exact in the middle, there's no net force, so the F is 0, which means that E equals 0 over Q, which is 0. So the electric field strength is 0. It's as if there's no field in the middle, because they've cancelled each other. Same deal, except the only difference is the electron will be pulled to this one and pulled to this one, but it's the same picture. Okay. 0 newtons per coulomb. Right, I think I'll let you do these now, and then I'll do them. And if there's time, we'll start the next lesson. I think there will be, because they're quite short to do, so we can have a look at the next lesson.
Only for
I know, I'm getting generous.
If the charged Q is double, what happens to it is smaller?
Oh yeah, I want a precise number. Does it double? Does it half?
Half.
Yeah. So you're already finished the first one, okay? So if you can everyone do these now?
What micro is it?
Yeah, microgram. Yes. Yes. Yes.
Oh my god.
Yeah.
What?
Oh, why?
Wait, what?
For the second one.
Yeah, and we have.
It's not, it's not. You
You
can't use G.
You go to the point.
Going towards the
U,
center.
V, A, T,
On the
S
right.
to get the A. And M, G, and M, A over the
Mm-hmm.
one uniform.
To get the
To get the-
Mm. Distance over one.
But you said that accelerate from that, so this
U
means the
equals zero.
acceleration zero.
No.
No, you.
U is
U is zero.
Yeah, I got, but
The A is definitely not zero. Because it starts from zero.
No, that's projectile. Don't do that. That's it. Okay. We have U, T, yes, U, T.
What we want is the A.
Equals V squared plus
T plus half of this one.
Two A.
U, T equals
V square minus V square.
But no, we can't use it because we don't have it. We're gonna use S equals U,
Yeah,
T plus
plus
half
half
of
is
T
plus
squared.
one.
the A is 0.001 over 2.
5.0.
Continue.
0.02. 0.02.
0.02, yeah?
Yeah.
But the micro is 39.
But then we have the kilo.
So it's -9.
Okay, okay.
Yeah, that equals 10 times, wait,
The microgram is 10 to minus 9. Or 10 to minus 8.
10 to the -9 kilograms.
Come to life. 2 to 9. Two to the 10 minus 8.
2 times 10 to the minus
10 minus 8 or minus 7?
How to do that for micro and
For micro it's 10 minus 9 and then mini is 10 minus 3.
multiply it by 0.02.
That's 3.
Yeah.
2 in
So in this one, number 3, there's, like earlier, 2 plates making an electric field between the plates. But this time, the field isn't strong enough to hold the particle in the middle. Instead, the particle is slowly falling down. So how strong is the electric field? So you know straight away it's not F equals weight, because I'm telling you it's not strong enough because it's slowly falling down.
You would also zero.
You take a 0, yeah.
It's the same.
Very similar to number 2, yeah. Actually, it's the same. Not quite. There is a tiny difference. It's very close, but there's a small difference.
F equals G, not M.
What do you got there?
Me.
Huh? What is that?
Me.
Yeah, what meat?
Find you yet.
I don't know.
I suppose you could taste it and to find out.
You
No,
can.
in Arabic, not in English.
You don't know.
Kofta, it's
No,
kofta.
In English.
No, it's not.
You say kofta.
If he doesn't know, then it's not.
Oh yeah, we use kofta kebab.
Huh?
You can taste it. Is it halal for you?
It's halal for me. All things,
Is it?
all things are halal for me. Let me break some off.
Yeah, you can eat it.
No, I don't want the whole thing.
No, give it to them. Make it take a count.
Try it.
What is the name of it?
I don't know.
There must be a name for it. Like it's the meat.
No.
I'll tell you. It's when you have a meat
You press it.
and you make the shape of it like that, like cylinder. You know?
Yeah, like a sausage shape.
Yeah. And you put it in the.
Press it in.
He's been a physics student.
Yeah, over. Just let it. Yeah.
But what animal did it come from?
So,
I thought so. So you put in a cylinder. So, a sausage. So I would just, you would still call it a sausage meat.
Yeah.
Here, if you take an animal and put it in a cylinder, like you call that sausage meat, even though it's not pork. So you could say like beef sausage meat or pork sausage meat. You know what I mean? So
It's not sausage.
no, you use the word sausage for when they take the meat, they ground it up.
Yeah, it's a machine and then.
Yeah, they ground it up and then they put it into a cylinder and then usually they boil it. So then you don't have to cook it much because it's already boiled. So you just maybe cook it for a few minutes in the frying pan like this. Yeah. So with the name you didn't know what you call this. You call it beef sausage meat. But I've never seen that before, so you must have got that from a halal store.
Oh.
no, from home.
Home country.
My mom is here, so she cooked for us.
But where'd you get the meat from?
From the halal.
That's what I mean. It must have been from a halal shop because I've never seen it
Yeah.
before.
No,
Yeah.
they do this also.
Do they really?
There are.
They
Maybe. Oh
You
yeah.
can cook it in home, but
Maybe at Tesco in a halal area.
no.
Yeah, there are some Tesco franchise. They have halal. The
Yeah.
one in Marion.
Yeah. City centre would.
Yeah.
Yeah.
Because they are Muslim. The one franchise that are owned by Muslims.
Oh wait, hang on. Your mother's here. Oh, tell her to come to the school sometime. I can talk to her. Yeah, do. How's her English?
She wants to.
How's her English? She wants to. Yeah, tell her she should.
No.
What's her English like?
Not good.
Is it really?
No, he will translate.
If anybody sees his mother around the school, send me an email immediately. I want to embarrass him in front of his mother. Oh, Miss Cherie, oh, such a good boy. Oh,
No, she knows that.
oh good. Oh, such a good boy, but he asks too many questions in class.
She will tell you good.
It takes so long to write down his notes. But a nice guy.
That's not bad, that's okay.
That's okay. I enjoy embarrassing students in front of their parents. I don't have much opportunity to do it.
Not here.
Not here. Sometimes. So I really make the most of it when I can. How are we doing with number 3 now?
I have 3.
It could be. Was the answer big for number 2?
No. No, it was okay.
Okay.
It was actually small. Like,
It was very small.
yeah, it was very small.
Then
Using the same. But the 200E is probably the same.
maybe.
What is your S.01?
In question
S is point oh. S is 0.1 because it's 10.
In 3 or the 2?
Oh, yeah.
Oh, and the open point. It was 58. So 80. No? What's 8? The 2 times 10 minus 3. Don't do it like me, I might be wrong.
No, that's, the A should be a small number because taking 10 seconds to travel 10 centimeters is very slow. So it should be a small number. Did you get an E? Electric field strength?
Yeah.
It's huge.
Yeah.
It's
One
huge.
over 2 multiplied by 1.
Okay.
Yeah, 1 to 4 and 3.
For what?
0, 1, 9, 2,
Equals
1, 9.
ET plus half
Yeah,
AT
it was
squared.
Yeah.
Half AT squared.
No, yeah, you're right.
Yeah.
The D square? No, it's not.
We're using S, U, and A. S, U, and D. Okay, so S equals UT plus a half AT squared.
No.
Yeah.
He's right, that is the formula for it.
Really?
Yeah.
UT?
S equals UT plus a half AT squared.
The positive T is 0. So half
100 T, 100 A.
When did your mother arrive? Was it yesterday?
Last week.
Last week, okay. And when's she going back? Open, is it? Alright, have you finished number 3 now?
I'm trying to move forward and I can't really, I don't know. But I skipped number 3 because
Not
yeah,
that.
I don't know my machine.
Close, but not that one.
What did you say?
Yeah, don't just stick with your answer and go to number 4.
Yeah, that's what I'm trying to do.
1, 2, 4, 8, 3.
Not this one, that's what Adnan was thinking. It's not simple harmonic motion. Think about your chemistry. No, think about your chemistry. What type of motion is an electron around a proton? Circular. So you need to be thinking about the circular motion formulas, not the simple harmonic ones.
So what's L? L. R.
I give you the or.
Yeah, okay. No, but
Pi
maybe.
r square.
It's not pi r square?
That's the area of a circle.
1 and 5,
Have we got number 4, the idea?
Do I use the R as L? Like 2 pi squared L?
No, that's a pendulum, so it's not that one. Do you remember the formula of periodic time for a circular motion? 2 pi over...
T. 2 pi over...
No, we're looking for
omega.
T. Omega.
Ah.
And what's the formula for... do we have... No, the formula for omega... you have other formulas as well, like A equals V squared over R. And do you remember what omega, or the other formula, V equals omega R? Yeah. So, and also, yeah, there is another one, A equals, I think, something like, oh goodness, what is it, like omega squared R? Although,
Yeah, A equals to omega square.
anyways, yeah. So those formulas together with the formula from today is enough.
We'll do it together.
Squared over R.
Yes.
Yeah, it's 10 to minus 8 multiplied.
Okay, we'll have a look at them. Right, so the first one, what do I say?
What's the V?
We'll do it now. F equals, sorry, am I looking for the F, is it?
Charge.
What happens to the electric field? E equals F over Q. So if I double the Q, then what will that mean is the electric field is halved. Yeah. 2, what am I given here? The mass is 10 to the minus 9 kilograms. What else am I told? The charge is 10 to the minus 3 coulombs. Let's work out the acceleration. I have 1 and 1. So I have U is 0, V we don't know, A we don't know, T is 1 and S is 0.01. And I would love to know the A, so I can use S equals UT. So it's a half AT squared. U is 0, so 2S over 2S over T squared is equal to A. Yeah? So 2S over T squared is 1 over 50.
It's 10 seconds.
The question 2 was 1 second. 1 over 50 meters per second squared. And what was I looking for? Electric field. Right, so the electric field is F over Q, and F is MA over Q. And we know the M, we know the A, and we know the Q. So M times A over Q. What's the Q? Minus 3, was it? So that is 2 times 10 to the minus 8. Yeah, and then if I multiply this by 10 and divide by 10, that would be 20. 10 to the minus 9 is micro newtons per coulomb. Okay. Right. That's number 2. Number 3. What's happening here? Oh yes, this is the 10-10 one. Okay. Here's the plate. Here's the other plate. And here's the particle. And it's moving down. So obviously the weight is bigger than the electric field, the force from the electric field. Yeah. Let's write down our info. What's the M? It's something 200 milligrams, or is it 2 milligrams? 2 milligrams. 2 times 10 to the minus 6 kilograms. What else do I know? The charge, don't I? Minus 200 E.
Times 10 seconds.
Yeah, okay, so we'll do a UVATS now. U is 0, V we don't know, A we don't know, T is 10, S is 0.1. So by the same formula, you can say A is 2s over t squared, which will be 0.2 over 100.
2 by 10
What's that? 20 over 1,000, which is 0.02. 2 times 10 to the minus 2. Huh? 3?
10 square is
Oh, I'm sorry. No, you're right. Right. I've 1 0 too much. It's, yeah.
2 to the 1,000,
Yeah, 2, yeah. So,
0.002.
0.002 meters per second squared. Okay. Right, now, how do we get the electric field strength? Does anyone know the next step?
E is
2 multiply 10 to minus 6 multiply.
Hold on, E is equal to F over Q. And what's the F here?
MA.
Good. MA over Q. Yeah, next.
2 by 10 minus 6.
We have the M and A and Q.
No, we don't.
Why?
You see, this F is this F. But this MA... yeah, we have not considered the weight, you see. This MA is the net total force, not the force from the field. If you look at the picture carefully, we want this F, we don't care about the W, and what we have is the total force. The total force MA is equal to 0.002 times 2 times 10 to the minus 6, which is, what is that? 0.002 times 2 times 10 to the power of minus 6. 4 times 10 to the minus 9 newtons. But that's not the F. That's not the W. What is that actually? Yeah, so what would it be in terms of F and W?
F total minus W. No, F plus W. Is it?
Which is it?
F minus
F plus W.
minus the F minus
If you want the final one, this one minus the weight.
no. F minus W. It's the total.
Yeah, so it's F plus W.
It is W minus F
What?
is equal to this.
I said that.
How? Wait, how?
Because
W
these...
is stronger than that.
Yeah, exactly. And the W is a little bit bigger than the F, so it's pulling it down like you said. And because they're in opposite directions, they subtract when they make the total. They don't add. So the F... Yes, I know, I recognize that you said that. So just to be clear for the video, Adnan has given me the correct answer here. I'll sign it for you here. Adnan 2017 Obama, yeah. No lols? Okay, no lols. Right, so F is W minus, F is W minus 4 times 10 to the minus 9. What's W? mg, so that's 2 times 10 to the minus 6 times 9.81 minus 4 times 10 to the minus 9. 2 times 10 to the minus 6 times 9.81 minus 4 times 10 to the power of minus 9. 1.96 times 10 to the minus 5. Newtons. Now that we finally have the F, you use this one, yeah. So now we can say E equals F over Q, which equals 1.96 times 10 to the minus 5 over minus 200 E, which equals, so I need to go back to the calculator here. Fraction, answer over 2, I don't care about the minus, it's a positive for strength. 23 is the constant for E. 6.13, no, 6.12 times 10 to the 11. Still big, yeah. electric field strength is defined as positive. If you want to be more technical, Musharif, the formula really is like this. Electric field strength is the magnitude of the force divided by the charge. Electric field strength is a positive number. It's measuring how much. You don't care about the direction. It's not a vector. It's not like force or acceleration. It's a strength. You don't care if it's up or down or whatever. It's the definition. Electric field strength is a positive. Okay, no? Yeah.
No.
No? Okay. Problem? Number 4? Yep. Right, what, do you have it still in front of you or not? What do I tell you in number 4? It's 1 electron orbits 1 proton, and I give you the strength. So you have a proton, and you have an electron. And you have an electron. And the distance here is 10 to the minus 10 meters as it orbits around, like basic chemistry here, yeah. I also tell you the electric field strength here, it's 1.4 times 10 to the minus 10 newtons per coulomb. And I want to know the periodic time. So, T, what type of motion is this? Circular. The formula for periodic time is 2 pi over omega. Okay, now you know from circular motion that acceleration is equal to v squared over r. And you also know that v equals omega r. So if I put that in there, I get the other formula, omega squared r squared over r, or in other words, a equals omega squared r. Now you might know that formula already, but technically this formula is not in the formula book. Strangely, they give you this one and they give you this one. So if you forgot it, you have to put them together to make this one. But if you remembered it, you can just use it. So that means omega is equal to root a over r. Yeah. So this is equal to 2 pi root r over a. Now that's actually looking pretty good because we know pi, we know r, we're missing a. But what does Mr. Newton tell us a is? F over m.
Why do you put R over A instead of A over R?
Because it's over omega. Omega's in the denominator. It gets flipped when it moves up. Likewise, this one becomes 2 pi root m or over f. Not so bad because we know the mass of an electron. I gave it to you earlier. We know the radius. So what are we missing now? The F. Do we have a formula for the F?
No.
What is it?
EQ.
Yeah. QE.
Wow.
Do we know M? Or Q, E? We have everything.
Do you have a key?
Yeah, because it's an electron.
Oh, okay, yeah.
Nice one.
Okay, let's have a look here. 2 pi square root fraction. What number is mass of an electron? It's 3, is it? ME?
Oh,
Yeah.
Sorry. Yeah.
3, is it?
Yeah.
Okay.
Should download the program.
I think I will actually make it my background or something. 10 to the minus 10. What did I say the charge was? 1.4 times 10 to the minus 10. And what's the other thing here? E. Oh no, sorry. That's the E, and now I need the Q, which is 1 electron. That's 23, isn't it?
Yeah.
Right, so this is everything typed in, and the periodic time is quite small. I think I'll put this in, what's microseconds is minus 6, isn't it? So let me just do 10 divided by 10 to the power of minus 6. So that is 12.7 microseconds. These are good questions for your revision because it tests that you remember your formulas, you know how to use your formulas, you can combine formulas to make something that you previously didn't know, now you do know.
That last thing.
Yeah.
That last thing you said.
What one? Which one?
Being able to combine formulas to come up with something you didn't know, but now you know.
Like the A and F, B?
Yeah, in other words, we started with T with a formula we knew but wasn't useful because we don't have the omega. And by continually using formulas to find things we don't know in it, we can end up with a formula that is new, that uses the things we do know. We'll have a little look at the next lesson, just maybe half of it or something. Please write this down carefully. Did you done that? Yeah.
So a question like this came up in the exam and it's like 5 marks or 10 marks, whatever. And
5 marks, I'd say, yeah.
and I just wrote 2 pi square root m r over q.
It's highly unlikely because that means you've memorized all the formulas for these situations. You know, technically, I suppose I'd have to give you the marks because you're using the right formula to get the right answer, and you've just memorized the formula.
Yeah.
But I don't think this would be the optimum strategy for revision. This approach.
But there is my formula stuck in my mind.
If you have a formula stuck in your mind.
I mean, omega squared r is like an example because we know.
That's an example which is, yep. And there is another one as well which we'll do later that's not in the formula book, but I recommend that you memorize it because it's common in the exam. You don't want to reprove it every time. Sometimes in the exam they actually ask you to prove it, but if they don't, then there's no need to. You might as well just use it. Who am I waiting for? Iyad, is it?
Yeah.
Okay. Right, so that's good because then that means